here today. Not a whole lot of new stuff we're going to talk about. The main thing, I just wanted to cover one more looping construct that we have. We have a do-while loop as well. We're going to talk about what that does. Then we're going to review some concepts that you'll need to know for the midterm, cover a couple of things that are important in this class. And then to finish off class, we're just going to work on assignment 4. So we'll get started then. So let's look at why we want to use a do-while loop. We will go through here and I'll write out a simple example of a menu. Yeah. So this would be how a typical menu would go. Inside our menu, we'd obviously have if statements that we're doing certain things based on certain choices. So we either say if choice equals 10, then we would say it was 10, or we take some action which required choice to be 10. Remember, we could do a switch case statement inside the while loop as well if we wanted to use that for our menu, but that's not what we're looking at today. So one of the things you'll notice when we're setting this up is one of our problem is we have to do something like this. We have to say scanf before, and then we have to have a redundant scanf afterwards. So when this runs, it's going to start at the top, and because we're going to enter the loop immediately, we need to read into choice right away to see if the user would input 0 right away. So obviously, we've looked at this before. Just going to keep reading forever and ever and ever until we hit 0. Because remember that 0 equates to false, 1 equates to true. That's why that works. It also, this works because any non-zero number, anything that's not 0 is true and 0 is false, in addition to just 1 being true and 0 being false, so keep that in mind. But anyway, one of the things that we can do is we can change our loop structure around by using a do-while loop. So we can delete this scanf, and instead of saying while, we say do, and then move this part down to the bottom. While choice not equal to 0. And what that allows us to do, the main difference between a while loop and a do-while loop is a do-while loop executes this entire body of this loop once before we ever test this condition. So thinking about how a while loop works again, just remember this. We test condition. This is while loop. We test the condition, then execute the body. So do-while loop is the exact opposite. So instead of testing the condition first, we execute the body first. And then we test the condition. So regardless of whether or not this condition is true, we'll always run this the very first time, again, regardless. So what we can do with that is we can take and we can move this scanf up to the top, and we'll remove that redundant scanf. So still works exactly the same, but we do remove that redundant scanf, and we're just when we're using a do-while loop, just remember that it's going to run this entire body first, and then execute and test the condition second. So not particularly important that you know that, but one thing that is important is that when you see this in the code, or when you see this in code you're reading, you understand what's going on. Most people will use a do-while loop if they need things to be executed first before they run, or before they test the condition first, instead of testing the condition first, like you would with a traditional while loop. So just keep in mind that you can use a do-while loop to kind of get around some of the traditional problems with while loops. So with that, that's all I wanted to cover today. I won't specifically need to know do-while loops for the midterm, but you can use them on the programming component if you want to. So do remember that the midterm is on Thursday. That's all we'll be doing on Thursday. Assignment 4 is due Thursday night, and your reading assignment is also due Thursday night, so just keep that in mind. Anyway, I just wanted to go over a couple of things that we covered in this class. Just remember we've talked about int. So if we have an int, it can store a whole number. It can only ever store a whole number. If we have a double, it can store a whole number as well, or it can store any decimal component if we wanted it to. So we store decimals in doubles, we store whole numbers in ints, we have char to store character values, so we could store a character like that, store something like that, could store something like this. I'm getting off here. Store a new line in a character if we wanted to. Store all sorts of different things. So one thing that I haven't really talked about is when we have a \n, that actually is one single character. So when we have a new line, the reason we use a \n is because we can't represent a new line in the same way. We can't do something like this. We can't essentially, we can't put if we put a literal enter here, that doesn't work. But what happens is when we put a \n, when this program gets compiled, that does get converted to a literal enter value. It's just we use a \n in our source code, so we know that this is a new line. If we had something like this, we couldn't really tell if that was a new line or not. So just remember that a \n is a single character value. Something we haven't talked about in a while was the tab character. So if we printed the tab character, we'll just do this. We will get a tab right here, so that will align things however wide they are. Just keep that in mind. So let's say we wanted to print a decimal to 2 precisions of, or with 2 digits. All we have to do is say printf %f, new line if we so choose, and then b. So to change that to go to 2 precision or 2 decimals, we say 0.2. Remember, left of the decimal controls padding, right of the decimal controls precision. So padding is the total width of the number in all. So if I said, when we're thinking of padding, we're thinking of this entire width right here. So if we say padding larger than the number is, the padding will pad off to the left. So right now we have 1, 2, 3, 4, 5 decimals. Remember that when we're printing a decimal number by default, we're going to print 6 decimals. So if we were to print this off just with %f, it would look like that, not like this. It would look like that, have an extra 0 there to get us to 6 decimals. And if we controlled the padding, what's going to happen is we're going to add additional characters on the left here. So I'll just go through, we'll start off, and we will look at that. Ignore all those warnings. So right now, without any padding or precision control, do remember that we are going to print that 0 there because %f prints to 6 places by default. So let's say we go over here. Let's say we wanted to do, let's say, what are we at right now? We're at 1, 2, 3, 4, 5, 6, 7, 8, 9 with that extra 0. So we'll do 10 point. That didn't do what I expected it to do. So I guess you'll need to manually put in your number of decimal places. I forgot you had to do that. So now we are printing spaces over here to pad it all the way up. So the entire length is 10 decimals. So this entire thing right here is 10 characters, 10 individual things. So if we want to align things, if we want to align numbers, we can use the padding. We can use the tab character if we wanted to. So using the tab character would have a similar effect. Remember that when we tab something out, it's going to align it. So let's say we had a number of a, let's say we'll print out B again, except we won't control its precision. You can see that it's a great way to align things if we wanted to. So that's printing and precision and stuff. That's pretty much all you'll need to know for that. So after that, we talked about scanf, I believe. So scanf is pretty simple. The three format specifiers you need to know for scanf are %i or %d for int. We have %lf for double, and we have %c for a character. So remember, you just specify when we're reading in. Let's say we wanted to read into E, we say scanf in our format string, %c, and then an ampersand in the variable we want to read into. We can specify multiple variables to read in by saying multiple format identifiers inside here. Don't have to be the same type. It could be a double as well if we wanted to. So we're going to read into 2 characters, and then our B, which is our decimal variable. So we're reading into E, reading into B, and so on and so forth. Just remember that when we're specifying our format specifiers, it does have to match the variable in the order that it comes. So we specify %c here. We need to have a character here, a %c here. We need to have a character here, and a %lf for our double. We need to have a double variable here. And the compiler should catch that if you do go wrong. And do remember that those are the same specifiers that you can use for printf. For doubles, you can use %lf and %f interchangeably. A couple minor things that will change, but nothing that should affect you at this point. So scanf. So we'll talk about if statements next. So remember, we can say if, then condition, and then inside brackets here we can say it's true. So let's test and see if, let's say, a is equal to 10. So that would print it's true regardless, because a is always going to be equal to 10. So just remember that there's a bunch of different operators that we can use. We can use equals, we can use less than equals, we can use greater than or equals to, less than, greater than, and not equal to are our relational comparison operators. So that's what all of those operators that we can use in an if statement are called. Those are comparison operators. So remember that we can chain multiple conditions together. If we want multiple conditions to be true for our body to execute, we can say and. So this double and ampersand is read as and. So we say a is not equal to 10 and a is less than or equal to 10. And we can specify multiple conditions forever and ever and ever as long as we want to. So we can say and. We can also say or. So when we say or, either of these conditions, if either of these conditions are true, we will execute the body of the statement. And then remember our final condition, our final logical operators. So when we say and, that's a logical operator. This is read as or. That's also a logical operator. Our final logical operator that we can work with is a exclamation point. And an exclamation point inverts the trueness or falseness of whatever this is. So saying a is not equal to 10 is always going to be false because a is equal to 10. We could invert that and say not a is not equal to 10, and it would just invert the sense of that. Obviously, we would never probably use that in this context. We'd switch and we'd use a equal sign instead of, or we test for equality instead of not equality. But we can use that exclamation point later. So remember, if we want to execute some code regardless of any other conditions, if this is false right here, if this is false, then this else block, or this else statement, and its associated block are going to be executed every single time. And then finally, we have the else if statements. So if we want to test additional conditions, we can say else if not equal 9, and test a bunch of other conditions and so on and so forth like that. Everything except these are obviously optional, but you can specify any number of them. Just remember you can only have one else statement, one if statement, and as many else if statements as you want inside of there. Okay, so talked about that. Going to talk about loops now. Remember that we've talked about 3 types of loops. We've talked about the while loop. So simple single condition right here. And then we talked about the for loops. So we have a init initialization separated by semicolons. We have the conditional test. And we have the increment. So as long as this condition here is true, then the body of the while statement is going to execute. And as long as this condition here is true, the body of the for loop is going to execute. So when we're writing this, let's say we get rid of all of these. We have int I, int n equals 10. So we will initialize. Let's count from 0 to 10. So we will initialize that to 0. Our conditional test will be I is less than n. And our increment step will be plus plus I. And then we will print off I every single time. Just like that. In order to get it to print all the way to 10, remember we need to change our condition a little bit. We need to say less than or equal to instead of just less than. Just like that. That'll print us all the way to 10 instead of ending at 9. So with for loops, remember that we can leave off any component of this. We can leave off this component if we wanted to. We can leave off this component if we wanted to. We can even leave off this component if we wanted to. So if we did leave off all the components, the only way to exit that for loop would be to say break inside of the for loop. So remember, when we say break inside of a loop, it will immediately execute the loop, and it will continue executing right below the loop. Let's say we went back here, and we had something like continue. What continue does is immediately stops executing the body of statements, and immediately goes back to the increment step, and then continues on with the condition step, and then continues on executing the statements. So remember, we could say something like this. We could test to see if I was even, like that. Let's say if I was even, we want to continue, so we will skip printing every single time I is even. So you can see we skip all of the even numbers like that. So when we're working with nested for loops, remember that we have multiple indexes. And we got to make sure we're incrementing the right variable. So I did something wrong up there. I'll come back to it in a bit. So you can see we're working on j here. We're testing to see if j is less than I. But I did mess up and I said I instead of j here. So if we did that, we'd get some weird results. Now let's see what would happen if we did that. So when we're running through our loop, it's going to enter the outer loop for the first time, and then it's going to enter the inner loop. So instead of incrementing j, we increment I. But since we're testing to see if j is less than or equal to I, what's going to happen is it's going to result in an infinite loop because it's going to never increment j, and j is never going to ever be greater than I since we're always incrementing I by mistake. So just make sure we are incrementing the right variables. It's also worth noting that you might see this represented either way. You might see ++j, you might see j++. Either of those do approximately the same thing. There's some minor details that are different, but we won't talk about that right now. For your purposes, using them in for loops just like that won't matter. They both have the same result. So with this loop, when we are saying j is less than I, we would consider this referencing the outer index. So when we're looking at our for loops, the variable that we are incrementing, typically the variable that we're initializing, we'd consider our index variable. So we have I equal to 0, I is less than n, plus I. So for our outer for loop, the for loop at the most outside of our scope, I guess, you can see that the index for that is I. And then for our inner for loop, the for loop inside of our other for loop, we have another variable that we are initializing 0, incrementing, and we'd consider that our inner index because it's the index of our inner loop. So inside of this loop, we see we have I here. So I is the index of the outer loop, so we'd say we are referencing the index of the outer loop. So let's say we wanted to print 0 through 10 10 times. Remember that this is going to control the number of rows we're printing, and this is actually going to print the columns for each row. So we can say printf %i space. Well, this isn't going to do it 10 times. If we wanted to do it 0 through 10, we would say something like that. If we wanted to say, here, we'll do this first. So in this one, we're not going to reference an outer index. We're just going to immediately print j. We're going to print j 10 times regardless of whatever the outer index is. It's going to not be controlled by the outer loop at all. When we finish our loop, we do need to have a new line to finish off the line. We can see we do print 0 through 10 10 times. Now we can go back and we can change that. Let's say we wanted to print it kind of like a triangle or something. If we reference the outer index is going to increase by 1 every single time. So we're going to result in 1 additional value being printed every single time. So this was kind of like your assignment for Thursday. I should actually probably go through and do that really quick. So you can see that it increases by 1 every single time. To make that controlled by the user, instead of assigning n to be 10 immediately, what we can do is we can read into n. So we can say %i n, and then whatever value the user specifies, we will count up by 1 every single time. Now, just remember that the important part about that is we are saying less than n here, so this entire thing will run n number of times, and then inside our loop, the important part is that we are referencing I right here. So just to take a look and see what's happening, for every, well, there's not much I can do. But looking at the results, just remember that right here, I is 0. So it's still less than n, so we're going to run the inner loop 1 time. When we're testing our conditions, remember if we're saying So we have, let's say for our first iteration, we do have I is equal to 0 right there. So we come into our inside loop here. We have j equal to 0, I equal to 1. We test to see if j is less than or equal to I. In this case, it is. If we had something like this, if we left off that less than or equal to, we ran this again, we are actually going to have a blank space here the first time we print, and we're going to not print the final loop. We're going to basically shift everything down one, and we're going to leave off a few prints that we really should be doing. So that was the in-class assignment from Thursday, basically, was to do that. Pretty straightforward, I think. Last thing I wanted to cover was random numbers. Remember that in order to do random numbers, you need to say include stdlib. If we want to initialize our random number generator to the time, we need to include time, but we'll come back and do that later. So let's say to start using our random number generator, we need to seed it with a value. Remember, if we seed it with a static value or a literal value, every single time we run the program, it's going to output the same. So let's actually do this. We haven't really done this much, but something we'll start working on pretty soon here is using random numbers in for loops. We'll just say less than 10, so we're going to print 10 random numbers, and we'll increment our index, and we will print a random number. And see, we get 10 random numbers. So remember, to control the random numbers, we do need to use the modulus operator. So we say rand mod 10. That will give us random numbers between 0 and 9. So all of those numbers are between 0 and 9. Let's say we wanted to do between 0 and 10. Just remember, this is our upper bound -1. Yeah, so we're always going to get values 1 less than this. So if we wanted 0 through 10, we need to switch that to 11. Let's say we wanted to do 0 through 100, we'd say 101, and that will give us values 0 through 100. Let's say we wanted to do 100 through 200. What we need to do is add to the result. So this expression will originally result in 0 through 100. And then when we add 100 to any number between 0 and 100, we're going to get numbers between 100 and 200. So numbers between 100 and 200. So keep in mind that is random numbers. But aside from that, I don't think I have anything more that I want to cover. Is there anything else that people want me to review before the midterm? Any stuff that you're still kind of fuzzy on that you want me to talk about more? If not, feel free to stick around, work on assignment 4. Do you remember it's due Thursday night? If you haven't started it yet, it's a real good idea to do so. So, although when you are working on it in class here, try not to work with neighbors that much. Remember, it is an assignment. It should be done individually. I should also note this is our first big assignment, and once we start getting to assignments that do have more code like this, it becomes much more apparent when people are taking code from other people. So I haven't said anything about it before. There always are more than no incidents where people are kind of working together, and when we have smaller assignments, it's not really possible to tell, but this is a big assignment. We should be at about, I don't know, 100 lines of code sounds about right, and when we do get to that point, it does, again, become easy to tell. So just keep that in mind. If you're doing your own work, you should be fine, but if you're blatantly copying off anybody else, I will take the time this time around to check that, so please do your own work. It's fine to ask for help from people, but if somebody asks you for help, don't just hand them your computer with all of your code. It's not the way to solve anything. Try and ask them questions to lead them in the right direction, or give them answers that will lead them in the right direction versus giving them the exact solution. So that's it. So ask me any questions you have about anything else or assignment 4, but that's all I have for you today.